Well, hi, good morning, and thank you so much for joining me in my shop here on June 14th. Oh my gosh, what am I going to do with this radio? This is no ordinary radio, that's for sure. This is a very unusual thing here. So, just in case somehow you haven't watched the earlier videos and you've somehow clicked into this one. This is a radio where somebody took the original tube set of low voltage battery operated tubes and swapped out all those tubes for typical 6-volt tubes. There they are. And then had to add transformers to the radio and make other changes which are too subtle for me to point to right now, except for one. They have to put a power supply, a rectifier and power supply here with a filter to filter the output of the transformers. To me, this is an impossible project. I would never attempt this. In fact, I just can't imagine attempting this. You know, unless there's something special about this radio, and I don't know. I don't know how somebody managed to get through it. So the fact is, the radio is here. The owner did say he was able to pick up stations on the AM side before I did anything to it, and so was I, weekly, able to pick up, I think, one station at one point. But now, after just changing out a few capacitors, the radio is not receiving any stations. It is definitely receiving. It's receiving noise signals and stuff like that. So there's really nothing obviously wrong with the radio at this point. That I'm aware of. That's the way I should really put it. And typically you would take tests and look at a schematic diagram and make assumptions and plod your way through, and eventually you'll find something. And oh, this capacitor is short. Oh, that resistor is open, and presto, everything's fixed up. I have no schematic. This radio's been altered to a degree I can't even know just how much alteration has taken place underneath. I've noticed a lot of wires don't seem to be laid out the way they would be in a factory, and there's just every indication that this is a real, I don't know what to call it, homemade soup radio. So, in thinking about what I can do, what can I do now? I think I really have to break this down into smaller pieces because it's too big a thing in itself, and start looking at it section by section. And the very logical way to do that with a radio is to go through it stage by stage. And usually each stage is really a tube. So a stage is built around a tube. So 1, 2, 3, 4. You could say there's maybe 5 stages in here. It's probably more like 4, but roughly speaking, that's how we can look at this. So what would stage 1 be? Which is where I would want to start. Well, stage 1 would be starting with the antenna connection here. I would say all the way to the grid of this tube, which is not a big journey in a radio like this. It should be a short journey to here. We can call that stage 1. We can call that the antenna stage. This particular tube is a mixer tube. Here we call it a mixer tube here in North America. We might get past this too. I might be able to realize what input is reaching the tube and then examine the output coming from the tube. We might get that far today. But my goal, when I will go away feeling happy, is to know when I put a signal into the antenna, what is appearing here. And that's probably a very easy thing to do. I think it's a very, very easy thing to do. I could do it with an oscilloscope, and we can look at the display and get the idea of how strong things are by how big the display is, or we can listen to it using my tracer, which I think is actually using this guy here, which I think is actually probably a better approach. And we don't even have to have the radio switched on and operating. The signal will get from the antenna to here through nothing more than a couple passive components. I imagine it to be a couple passive components, like a resistor or a capacitor. We don't need the tubes operating. So I'm going to want to feed a signal in here, and then chase it through the radio, basically. Chase it to here. So this will be connected to the signal generator. Let me just Do you think there'd be an easy place to clip this? Here we are. Here's an easy place. So the smoke has lifted from around here, at least yesterday. Smoke from all the wildfires in Canada, especially the smoke here was coming from the fires in Quebec, which are maybe, I don't know how far away they are. 400, 500 kilometers away, something like that. So that's nice, and no rain today. Okay, so we'll put this ground on here too. Okay, look at the probe here. We're going to turn this guy on. So this is a radio receiver, and it tunes like this. It will receive the AM broadcast band. It will receive a range, a lower range, which covers most IF frequencies. And it will also respond to audio if I wish to use it that way. So we're going to be looking for a radio signal coming through from the antenna. What I'm going to do is I'm going to set this. Where's that coming from? Okay, a little noise out of my tracer, but we won't worry about it. It's still warming up, so we're going to set the frequency here to something within the range of the radio. Let's set it to 900. So there's a signal coming out of here, a fairly strong signal at 900 kilohertz, just below 900 kilohertz. So what I'm going to do now is we're going to tune this guy over here to 900. So we're on band, well, that's a little loose, band A. No, we want to be on band B, RF. And then we want to set it around 900. It's just about where it is right now. Okay, so right here, that's 900. So we're going to put this now. Come down, come down, down, down. We're going to attach this to the output here. A little bit less volume. Okay, now that is what's coming out of the signal generator. Just going to set this up properly here. So I'm closing the magic eye. That's our starting point. So we'll be able to use this as a bit of a, not really quantitative, but semi-quantitative observation, along with listening to the volume in our ears. So let's tune it in here. Very accurate, right on 900. Very good. We'll just jump straight to the grid here. Whatsoever. Now, this radio also has to be tuned to 900. It is. It's sitting right on 900. It's absolutely nothing coming through there. I kind of got my hands blocking the view there, don't I? Oh, let's check this out. Not a thing. Not a thing making it through. Should we say that one more time? So there's another, so this wire connected here. Where's the wire coming from the antenna? It's down under here. But it's the same connection as here. They're just so nothing at all is getting from the antenna to the first stage of the radio. And I've been suspicious of this all along, frankly, because of a few other things that have happened along the way. Let me rearrange this a little bit so we can tip this guy up and get underneath it. And I'll tell you what my suspicion is. My suspicion is the fellow who worked on this messed around with the band switch and never got it sorted out. Now, is that really the case? I just made that up, so I honestly have no good reason to believe that. take it all the way around? Yes, we can. Okay, now we're just going to trace the signal where it comes in. I'm going to have to, my tool is limited here. Yeah. Not something most men want to admit to. Okay, there we go. Slide this way. Get it over here. Getting a little crowded. Okay, signal is coming in. No, it's not coming in. Let me do this. Let me take this off here. So we'll clip this onto the antenna connection here. Same thing as, excuse me, same way I had it. Just from behind. Check. Okay, that wire runs over to this terminal on the switch, I believe. There it is. Now, where's it going from there? There's a number of terminals on the switch. What I'll do is we'll just go around and try to find a terminal that the tone is on. Start again with this one here. Whoops, where'd it go? Did I not touch the right thing? No, I did not. I did not touch the right terminal. It's this one. Okay, where else can you be heard? In there. Too far in. Let me try something. Kind of clumsy here. Okay, and this is the one that it's on. So what? I think I blocked the camera, didn't I? So put the screwdriver on the terminal that has the signal. Put the screwdriver on the last terminal I couldn't get to. There's no signal showing up anywhere in the switch except where it's going in. What is that all about? How can that possibly be? Let's take a look at the switch itself and just kind of examine how it's set up. Okay, so I see the automatic focus is on here on my camera, so I'm quickly gonna turn that off in favor of fixed focus. Okay. Now, I did notice before the switch was quite black, but where the contacts are, it's not. So I'm going to put this into is what I believe to be is the broadcast position. That's the middle, right there, middle position. Okay. The wire that the signal's coming in on is this terminal here, which you really can't see. Okay, with that terminal. This wire doesn't feel like it's soldered. It's kind of clicking a little bit. I don't know. Okay, the wire we're interested in is one that's coming up down here, this one here. It's got the signal on it. But we really want to look at the contacts on the switch. That's really what we're after here. Okay, so getting the right terminal. Has to be that one. Let me put a stick on it. It's easier to see with my eyes than it is with... Okay, so I have this stick pointing to the terminal that has the input or antenna lead on it. Now I'm going to figure out that one has to be, what's that on the end of my stick, a little piece of solder? Where'd that come from? Okay, so we're looking now at the switch. You can see the switch is connecting to here. So this red wire should have the antenna signal on it. And that red wire is connected to the bottom of this coil here. Wow. You can definitely see that that's all been resoldered down there. How do you get a soldering iron down there? Here, just look with the other camera here for a moment. You can see where I'm looking. I'm looking down through all this. Down in here. Well, I stuck my finger in there. I guess you can get a soldering iron in there. Well, it's a signal there. The signal will make it there. So again, the switch is set. We saw it. We saw how it was set. Double check this, make sure it's working. Yep. There it is. So it makes it to this coil. Well, coils. So this form has what appears to be 3 different coils on it. Oh boy. Some schematics would reveal a lot about these coils. Other schematics won't, but I don't have a schematic, so what do we got going here? We've got wires here, 2 terminals here. We've got something going on low down there. Look at these wires here. Oh my gosh. So one possibility is this coil is defective. It's burned open, or is misconnected, or something's going on. Can we pick up the signal in any other terminal here? Let me check it again. Yeah. Weakly. Very weak there. And where'd that screwdriver go? I can't really tell. Is that 2 terminals down there? Let's go with the camera here. Take a look. The red wire is carrying the signal, and it would appear that what has happened here is the red wire has either been extended to pick up that terminal there to the left. It all looks totally connected together, doesn't it? It really does. Can you get there? Just getting close to it, I can hear it come out of the speaker there. I can't. Okay, it's really pushing out a lot of stuff here. Well, just by it's definitely on that wire. I think it's definitely on that connection. So you would guess, I would guess, there's another connection on the other side of this coil, but that would put it way down. And sure enough, I think there is a connection down there. Wow. How would this be? Got Also looking up at the windings to see if there's any indication of overheating, burnout, rust, like green corrosion. Let me put this right in here. I'm going to change the focus a bit. Boy, oh boy, oh boy. I mean, taking these coils out, not really a good idea. Just bear with me. I'm just going to fiddle with the focus a little bit. There. Actually, it's focused pretty good. What exactly are we seeing down there? Bring on some more light. So, see a large terminal. You know what that is? That's a capacitor terminal. So there's a bank of capacitors right here. 4 of them. 4 trimmer capacitors. So if we follow that wire this way, oh my gosh, looks like it's soldered. Looks like it's soldered to the other capacitor. So, you know, the way they've arranged the radio is to position these capacitors right up tight to these coils, which I'm sure is done for a good purpose. Well, why would these, like, why are these wires disconnected and reconnected? What was going on here? Yeah, that's a good question. What was going on here? So, the other terminal, let's do this. Well, we're on that. Okay. Talking to myself here a little bit. Actually, the whole thing is me talking to myself. If we look inside, we can see a wire from this terminal here going a short distance. Is it a short distance? Well, doesn't go all the way to the bottom. Down at the bottom, can't really see anything. Oh, that's nice. I don't know what to make of it. So sometimes the wires are brought inside these tubes and then fed up to the terminal, like you see this upper wire. But other times, no, they're just on the outside. They never go inside. Any evidence of damage in these coils? Any evidence that they've burned up? They shouldn't really burn up because it's part of the antenna circuit. But I guess conceivably you could get a lightning strike, or lightning in the area would potentially burn one of these guys out, but I just don't see it. You can imagine lightning is pretty exciting. If lightning goes in your radio, it's not a little tiny pip. Well, can I get a probe down onto there? Well, the other side of the capacitor. No, the other side of the capacitor is probably mostly grounded. Let's see what's going on with this capacitor bank here. Well, it's not obviously grounded. It's what's going on with that? Right there. What is going on? Right. So a wire right there, which goes up. It's the wire coming through. So it's coming through here. There it is. Pokes through, comes out, and comes over and gets soldered. But again, this is a... Well, what is this? What is this anyway we're looking at? It's a transformer, I would want to bet. And why it's got 3 coils? It's probably got 2, but one of them is wound with a bit here and a bit here. And this could be a way in which the bandwidth is being controlled. Now, I don't know that for sure. Like a lot of things I say on these videos, you know, take it all with a grain of salt. All you're hearing is what's in my head. Well, yeah, I said, let's look on the schematic. Well, we can't look on the schematic. So typically, I would think one side of this antenna coil would be on the antenna like we see it. The other side would be grounded. So it could be the far side of these capacitors that are connected together. You see a wire connecting them? That could be a grounded thing. Not necessarily. At all. Well, so we may have hit the spot here where there's a problem of some seriousness, and that this coil is not doing its job at all. I mean, we do hear something. Let me touch here. So there's something being transformed. Down under. Trying to do this so you can see what I'm up to. Nothing there. Let's just try this again on the input side. It's all there. It's all there on the input side. So if this other side is grounded, I'm not going to get a signal. So how would we know if there's a signal radiating inside this coil? We take another, use a pickup. Use a pickup coil. Just looking at the windings there. You can look at things like the coil's conductivity, see if it's open circuited. We can probably do that with these two terminals quite easily. It's the wrong part of the coil, but maybe it's the problem. Maybe the secondary is the problem, and I don't know. I have to try to force myself to not get caught up in assumptions. It's really easy to do that, just without even realizing it. You might think, oh, the problem has to be the primary. Well, maybe it doesn't have to be the primary. Okay, what kind of resistance do we see here? Well, 0. So I think that's pretty much a good sign. I put this on 600 ohms, but I think we're still going to see a 0. Let's see. 5.2. So that's a very good reading, suggesting that whatever coil these terminals are connected to is fine. Now what about the other one? So we tried the other one that the antenna's hooked up to. Okay, so I think I'm on one side. Can anybody see the meter at this point? I get no response. Now I may not have gotten on the right contact here. Let me try it over here. Just any momentary. There it goes. 17 ohms. Well, that's also a very realistic reading. So what are we seeing here? So we're seeing signal appears to come to that coil. Coil appears to be intact. So that thing should be radiating at the frequency of my signal generator. So I'm going to stop for a minute. We're going to do the SDR thing. I'm going to sniff around for that signal a little bit around that coil. Okay, Okay, while I was drinking my coffee, I realized I didn't try tuning the radio to see if that would affect the result here. So once again, let's check. That's what's coming in. Get it here very weak. Does it get stronger if I tune? It does not. It does actually. This is weaker here. Not by much. You might have trouble hearing. I can still hear it though. But it's definitely not tuning. It's not tuning it in. Now let's put it right on the actual lead here. Do the same thing. Why? Just to see. No, it has no effect. Okay. SDR, right. I'm halfway through getting that together here. Okay, so you can see my SDR there. This is the SDR antenna. And what I have here is just a single turn loop here. And a pretty minimal effect. You can imagine this is pretty much a short circuit on the antenna input to my little SDR. That's good. I don't want this to be too sensitive. I'm going to stick this down the tube here and see if now, wait a minute, I was going to say see if we can see something at 900. There already is something at 900 there. What's going on there? Right here, bang on 900. Is that the signal generator? Don't think so. No, you cannot see the signal generator. That's good. I'll set this to 1,000,000. I can't get to 1,000,000 from here. Okay, I'm going to set this to... Okay, let's pick 800. 800. There's nothing at 800, is there? 800. Okay, we're at 800. There's nothing on the screen at 800. So I'm going to hold this near the output of the signal generator. Nothing showing up at 800. Again, that's good. So what I figure is the output from the signal generator is going into this coil, and then with the coil it's going to be much easier for this to pick it up. Let's find out. Here we go. We're going down. We're looking right around 800. I don't see a thing. So there's a general rise in the noise level on the SDR. It's not much of a rise. Right now the line here, the signal line, this part here, is just below -50, and when I stick this in here, it's just above -50. Maybe it's my hand. Yeah, it's my hand. Well, no sign. I'm going to put this up. Strong signal now. We should be able to see it. I'll try it right near the wire. Don't see anything. We're going in here. There. Whoop. Did you see that? Now there's a 1 second delay. Why is it behaving a little weird? It's going real slow. So there we are. So this is suggesting now that the coil is actually operating. It's not, suggesting is the word. So I'm able to move this tip past the coil. I can get it right down to the chassis here. But just as I'm passing the coil, it's 943. Hang on a sec here. With the 4 sticking out. Right about there. Yeah, sure enough. When I get this right under the coil, it shows up, but if I just put it near the wire, nothing. So my thinking is the only reason this is picking it up is because the coil, come on clock, will you stop? Thank you. The coil develops a field and it's acting on this. If the coil did not have the signal going through it, if the coil was open circuited or something like that, then I think we wouldn't see anything. We would see the same thing that I get just from touching the wire and nothing. So this is suggesting the coil is operating. It's pretty convincing, actually. Because that's not just a little bit there. That's a pretty strong signal. Now what happens if I tune the radio now? Let me put this so I just set it down so it's fixed in place here. In some way, I'm not holding it. Give me something heavy. Thank you. Okay, tune the radio now. I don't know what to expect. I just wanted to do this. Change the band. Now that's interesting. So I put it to short wave, and you see how it's just quit. Go back to broadcast. We'll go over to phono, what I believe is a phono setting. So it's pretty clear that this switch is, and we saw it physically. We saw the switch do this. Coil is good. Primary coil is good. Now, I am assuming that this is a transformer thing. So the antenna is energizing the primary, and the secondary is what's hooked up to the tube grid I was testing earlier, where there was apparently no signal. Now you'd expect if I put this in the coil, in the secondary coil, there'd be quite a reaction. There is quite a reaction. Go up, down. Oh, it's only one up and down. Let's just come back real slow. There was two ups and downs there. How far out am I here? So I'm practically out. So I think I'm seeing both coils now. Let me go down slowly again. You think the secondary might produce a bigger signal than the primary, oddly enough. Let's go. Here we go. Going down. Very slowly. Something coming up at 800. Very slowly. It's still going up. It's going up. It's coming down. Coming down. It's coming down. And it's all the way down. It's just one. It's just one. Oh, what was that right at the end there? You know, I touched it with my finger, I think. Come back out. Goes up. So I'm trying to tease out the two fields, the primary field and the secondary field. Well, I think, based on the location of this, that I'm seeing the secondary field. So why is it not? Why is it so weak? Why so weak? I would guess it would sound stronger here. This probe, by the way, is the grid of a tube that's inside here. That's why this is so big. There's a tube in here. It's actually getting warm from the tube. This is the grid. What that means is the impedance of this and the length of it, there's virtually no load coming from this guy here. You can put it almost anywhere. Okay, let's look closer at the secondary circuit here. As best we can. So I've only seen 4 wires going in and out of this guy. So we're going to assume it's a transformer. The primary is the one down here, and these two are actually a single secondary. Secondary terminals are here. One of them I can hear a bit of a signal on. This one, where's it going? Where are you going? Where are you going? Let me get a stick here. Hey, where'd my favorite stick go? Here it is. So, I'm going to have to use this close-up camera. I want to see what's connected to the lower terminal in there. Trying to see the lower terminal. That's a good view of it. Now, is that terminal that we're seeing, the capacitor terminal, is that connected to the terminal just behind it? There's another terminal connection behind it. I have to kind of look down at it here. I might put this right inside the radio. Good thing I'm doing this with the radio switched off. Now, where are we now? We are... Let me put the stick in here. So we're trying to see... So this is the top terminal, bottom terminal for its out of view. So I'm looking at the wire, not the red one, this one down here, this guy. Where's he going? I think that wire is connected down here. So I see the green insulation. I'll wiggle the wire a bit. Try to wiggle the wire a bit. This one here. Okay. Well, looks like it's going right past. Oh, it's going way down here, so no, that's a red wire. There's not too many places we can go. It looks like it's going right past the coil, though. Can't see in there. Okay. Now I'm going to get my stick. This guy here. No, you can see it moving way over here. Oh, that's the red wire that's moving though. How's this work? This red wire, I'm moving the green wire over on the left here, and the red wire is going. You can actually see a bit of the green over here somewhere, right over here. This guy here. Is he jointed to the red wire? I thought I traced the red wire way down here. Yeah, for sure. Must just be bumping into the red wire. And bearing in mind that there could be some very fine wires in here that I can get my stick on it and break them. Okay, what have I got now? I've got this. The stick is following the green wire. Oh my gosh, this is just crazy stuff. It looks like it's terminating right here. No. Wire. Where's that green wire going? Is it going nowhere? Is that the problem? Yes, the red wire and the green wire look like they're tangled up a little bit. I can see it coming right to this terminal. Comes to this terminal. So what's hooked up to the other side of this coil then? Could it be it's connected to that capacitor terminal? Here. No, not here. Here. This one. Orient the radio a little bit. Sure looks like it's connected there. Also looks like it's been soldered at. Looks like some of the wax is melted off the turns of the coil here. And that could be just a wild guess from holding a soldering iron down in there. Maybe even bumping the coil a bit. Okay, so if that's it, that's the other terminal. I'm trying to spot the wire coming out of the coil. Put that fat chance on that happening. It's inconclusive here. It sure looks like it right there. Okay, so what would that mean? That would mean this other connection would almost certainly have to be a ground connection. So let's get out the ohm meter and we'll see. Let's see what we can find here. Is it grounded? That's the question. Are you grounded? Okay, so we'll ground one thing. The other. First, we're going to go on the input wire. Just see what we got. Didn't we get like a 6 volt, 6 ohm or something like that last time I did this? $17 ohms through the coil to ground. This capacitor, not grounded, not grounded, not grounded, not grounded. Now how about the other side? Not grounded. Did I lose contact here? No. In there. Can I make it? Yeah. Not grounded. What? Wait a minute, wait a minute. I touch up here. We get 17 ohms to the chassis. Now if I touch the other terminal, we get a 0. Good. Okay, that all adds up. It's always great when all the pieces fit. Okay, so that pretty much proves the primary is intact. The secondary seems to be intact too, but the very, very little signal coming out of here. Now, why is that? Could be everything from wiring mistake to a component that's dragging it down. Where does it go from there? Assuming that's what's happening. What would we be doing here? If you have the secondary, on the secondary side, you want to feed in the AVC voltage through the coil into the grid. Is this to the grid? Does this go to the grid? Doesn't look like it. Looks like it goes to an IF. Well, it goes to a terminal on an IF transformer. A bunch of other wires are going to. And the other way we go down to this capacitor. Right, the other terminal is a ground, so it doesn't matter that it's a capacitor terminal, it's just a ground terminal. So we come here, we have a trimmer, trimming on the secondary side of this transformer, And we have this going over here for some reason onto the switch. For reasons, oh my gosh, I wish I had a schematic. Now, so how does it get up to that tube? So I'm going to take a look at the tube situation here. The tube is fed with a wire coming out of the IF. And the IF is this one here. That doesn't make sense. No. It should not be coming out of an IF transformer. I'm looking at the wrong tube. Wrong tube. This is the first tube. This is the one whose grid cap we should be interested in, and it's hooked up. Well, it's hooked up to the top of the capacitor, so which is the same as being hooked up to the bottom of the capacitor, which is right on this wire here. Great. So what's that mean? That means if I take my ohm meter and double check this, we should get a 0 between here and the grid cap on this tube, which you cannot see. Right in here. There we go. See, the meter dropped to 0. Okay, so that's the grid. Let's look at the switch now. This is in broadcast position. What is feeding to the grid? What is that switch doing? What are you doing there, switch? Hang on a sec. Okay, looking at the switch now. Did I mention something about how painful this would be to do this step by step? And you have to have certainty every step of the way. You cannot afford to say, I think that's what's happening, and carry on. So I think the wire we're interested in is this one here. I'm pointing at that guy. That's the guy who goes up to the grid cap, and you can see the wire going up and disappearing through a hole, heading up. Up. So what's the switch doing now? The switch... So this wire is connected through the switch. Excuse me, to this one. This one, which is this one. Oh. So that means this is connected straight up to the grid cap. Wait a minute, what's this wire here? What is that? Well, I guess what they did is they've just pushed the wire from inside the form here through a hole in the terminal. It comes out. They wrapped it around the terminal and soldered it. That's normal. That is normal stuff. Okay, not something weird. So I should be able to go all the way from here to that grid cap and get 0 resistance. Grid cap. Cap is a cap on the tube. Okay, let's switch over here. Okay. Grid cap. Okay, so I'll get on the grid here. Okay, and right to here. I get a 0. And if we open the switch, did that open it? Yes, it did. Close it again. Yes, sir. So we have a wait a minute. Did I turn it the wrong way? That's broadcast. That's a 0. So we have the antenna feeding the primary coil if everything appears to be okay. Primary coil should be energizing the secondary coil. Secondary coil appears to be okay. Secondary coil output is then fed on this wire through the switch and on up to the grid cap. We have a weak signal here. Why would that be? Why would it be so weak here? Because the transformer is open circuited, but I read the resistance between these terminals and got something. It's a false reading. It's not disconnected from the circuit, so you can take readings of stuff in a circuit, and you're reading other stuff in the circuit without realizing it. Well, if I get this here, I should get the coil resistance here. There it is, 5 ohms. And then this wire is going over to here, which is probably just a ground. 5 ohms. It's not a ground. Wait a minute. Yeah, is it grounded? Come on, show me a ground here. No ground. So what's that all about? So the wire, so you have one wire going to the grid, the other wire going over to here, which is one of the IF transformers. So conceivably this would be the no, the output from here should be going up to the mixer tube. What's it doing going over here? So there's a couple other wires on here. One of them goes way up to here. And the other one, the red one does go back to this tube. Goes back to the first tube. Definitely. Oh, that's right. Then there's this wire. Oh, it's not a wire to nowhere. Hold your fort there. Careful now, Jimbo, remember? This coil. What is it? This also has a complicated coil here, similar in structure to this, except it has this part, which is similar to here. So I was thinking this is the local oscillator coils. You're switching between them for the different bands. But you'd also want to switch off of this transformer onto another transformer. And so here's one sitting right here. Again, the wires are extended. That's not my capacitor there. There's a piece of paper shoved down into it and a wire connection. Instead of going to a terminal, you have a wire which looks like a winding wire connected to this red wire. Oh my gosh. Oh my gosh, what is going on? Just a wash. Just a wash in wires here. Okay, let's back up a little bit. So I found that the grid of the tube is connected right to here. Found a very light signal here, but nothing here. This other wire is going over to here. Where? Well, why would that be? Why would that possibly be? You'd have the antenna circuit connected to an IF transformer. Is that really one of the IF? Yes, it definitely is. It definitely is. Definitely is right in here. The IF transformer should have 3 leads going to it. 4 really, but one of them is coming out the top. It's going to the grid of the second tube. So of the 4 terminals, 3 of them should be produced at the bottom here. I only see 2. I only see 2. I said that twice. I only see 2. So you see there's a terminal on the top left there with nothing connected to it. It looks like nothing ever was. That's probably the one that's going out the top. We have a terminal here, obviously, with a bunch of wires connected to it, including the one I'm interested in. You know what? That red wire is not connected to the same terminal. I think these are separate here. Did they get shorted out? Yeah. Give me something a little less clumsy than a great big screwdriver. Yeah, that's the case, all right. That's going to a different terminal. So there's the 3 terminals, 4th one being on top. So now we have, so I thought this wire, which is the one I was chasing, was connected to the red wire. Only through the coil, if it is at all. So we come here, and then where's this green one go? This green one takes a long trip through the radio. What, did I hit it? Did I find it? I won. I just won. I won something. Tell him what he's won. I can't really see where it's going. Okay, it's going somewhere. Oh my gosh, there's that wire I was talking about where it's just coming right out of the coil and then tied to just a piece of wire hanging there. Oh boy, oh boy, oh boy, oh boy. Now, I've done lots of things in radios that are precarious. Wow, this one's full of precarious stuff. Okay, so did I clear a short down here? I don't think so. It's possible, but I don't think so. How would we know? We have to run the radio. So, I think coming to this point is this green wire, which is coming from here. That's my meter saying goodbye. Coming to here. The other wire here is going, so this is going to the grid cap. This is coming from, from something? Wait a minute, no, this is a transformer, so it's generating energy between these 2 terminals. Why in heaven's name is this hooked up to the IF? Could these look original? This doesn't look resoldered. This looks original. Can't tell what's going on with the red wire. So I have original green wire. Did he hook it up to the wrong spot over here? This wire is long enough to reach all kinds of stuff. And for all I know, the guy cut it and forced it in here. Does this look redone? I think it does look redone. Oh. Yeah, that's how I'm feeling about this. Oh my gosh, how am I going to get through this? Oh my gosh, I'm stopping for some coffee because I just don't really know. I don't really know how to approach this at this point. I mean, I had a schematic, the whole situation would be different. Has one of you found a schematic for this radio? As you may know, I don't normally read comments. Occasionally I do, but normally I don't read comments for a long list of reasons. Not the least of which on that list is the amount of time involved. So someone may have made a comment and said, "Hey Jim, hey, schematic's over here." but I didn't see that comment. So somebody, anybody, email me with a schematic for this radio, if you can find one. Could there be? I mean, there can't be. If my theory's right and this radio has had the tubes completely changed in it, then there is no schematic. But we've no reason to change all these coils. I don't get it. Jeepers. Yeah, I'm going to stop for a bit, drink some coffee. Maybe I'll come up with a better idea of what to do next. Well, we've reached the point here where I have to go to the grocery store. So I'm done for today in here. I'm really not sure what to do next. I'm really not sure about anything. I just have question marks and doubt about everything I did this morning. But just to recap it, it looks like the antenna transformer, let's call it that, seems to be okay. The primary seems to be wired in correctly. The secondary, it's hard to explain. It's hard for me to understand why the secondary side would be connected to an IF transformer terminal. Not making a lot of sense to me. I'm going to leave it at that because the grocery store awaits. So thanks a lot for watching. I got to warn you, this is going to get even hairier and just even more confusing, I'm sure, as we continue along with this. But I don't plan to give up. Okay, see you later.